right, some of our properties of equalities, and then just solve some equations on the board. Okay, so let's go ahead and get started with that.
Just crushed Oreos.
Oh.
Now I'm messing with these crumbs on my computer. Oh, back. That's my favorite.
All right, so first property we got, it should be pretty obvious, right? If I have some number, right, or something here,
Okay.
hey, if you guys could just be quiet, I should zip through this quickly, right? Just wait until after I'm done to talk. Right. So if I have some, right, some number x, that's just equal to itself, okay? That's the reflexive property, okay? Just means that, right, 3 is equal to 3, 4 is equal to 4, you know, whatever. Right? Second one, right, these ones should be pretty straightforward, pretty obvious. And in fact, like all of the properties of equality, I think they are. Right.
The door is open.
All right, this next one here, we have that if some number y is equal to a number x, then x is equal to y, right? Basically, whatever we have on one side of the equation, okay, we can flip-flop it, we can reverse it, and we're still making the same statement, right? If y is the same thing as x, then x is the same thing as y. It's called the symmetric property, right? Same thing on each side. We can flip it, it doesn't matter. Then we have the transitive property. Right, Lewis,
Yeah.
maybe quiet, please, just, right, like, while we're going over this, just don't talk. All right, next one, right, we have our transitive property, okay, and that's going to say, right, if x is the same thing as y, and y is the same thing as z, then it must be the case that x is the same thing as z, right? It's called the transitive property. Hopefully this should be pretty obvious, right? This should be pretty obvious to you guys, but, you know, comes up a fair amount, right? It's we can kind of extrapolate information from doing that a lot. All right, any questions about these three? No? All right. So let's move on to just some multiplication properties, just to remind you guys. Because when we get into solving quadratics, it's not today, but these will come in handy. All right. So we got our... And who's playing music? Who's playing music? Right, yeah. Okay, let's turn it off. All right, you guys should all know this. If I multiply any number by 0, then that's just going to be 0, right? 3 times 0 is 0, 12 times 0 is 0, yada yada. Okay. All right, bro, what this is going to help us is that if I have an equation, for example, like, right, a times b is equal to 0, then, right, either a is equal to 0, or b is equal to 0, right? Hey, and that should stick out, right? A times b is 0, then either a is 0 or b is 0, or a and b are 0, right? Inclusive or here, it means that it's either one or the other or both of them, right? Either a is 0 or b is 0 or a and b are 0. Okay? This is going to come in handy when we're solving quadratics, right? You can factor it out and then set each of the factors equal to 0, and then you get your solution. Okay. We're not doing that quite today, but you know, it's good to be aware of it. All right. Any questions about this before I move on? Okay. Now we're going to go into just a bunch of stuff that is going to come in handy when we are solving equations. And basically, we're just using, I thought about doing the algebraic properties before this, but I think you guys should all know them by now. Basically, we're just dealing with inverses, right? Move on. Alright, basically we're just dealing with inverses, okay? And that's kind of the idea behind solving these. But let's just go through what this means when we're doing an inequality. Basically, big rule here is just whatever I do to one side, I just have to do to the other. Okay, that's kind of the theme going forward. We're just going to go explicitly define them for each operation. Okay? We have the, right? Okay. Addition property. Alright. If x is equal to y, then x plus a is equal to y plus a. I just have to add a to both sides of my equation. Because if I just add a to one side, that doesn't make sense, right? I have to add a to both sides of my equation because x and y are equal to each other. Okay, same thing with subtraction. If I subtract some number from both sides, or from one side of the equation, I have to subtract it from the other side of the equation for the equality to remain true. Okay. Same thing with multiplication and division. I'm just going to put those up here. Okay, so basically just for all of our operations, whatever I do to one side, I do to the other. You know, I'm not going to state it up here, but this does hold for exponentiation and like roots, right? If I raise one side of the equation to the second power, I have to raise the other side to the second power. It's not going to come up too much today, but these will, right? If I have Right? If I add some number to one side of the equation, I have to do it to the other. If I subtract some number from one side of the equation, I have to do it to the other side of the equation. If I, right, let's be quiet, guys. If I multiply some number to one side of the equation, I have to multiply to the other. And if I divide by some number to one side of the equation, I have to divide it by the other. All right. Any questions about these? Again, the equality properties, I think they're pretty easy. Right? They should be sort of obvious. Right? You just got to remember, right, when we have an equality, that means the same thing as or equivalent to, it's the same thing, right? So any questions here? All right. So let's go ahead and get into solving our equations. And I'm going to do one, and then I'm going to ask for some help on the next one. Okay. So let's suppose that we have okay, we have the equation 5 times x minus 3 is the same thing as 2 times x plus 6, okay? Main idea here is we're just going to use our properties with our operations for equality, and we're going to be looking for inverses and identities, right? What that looks like, it should be familiar. I'm just going to go through this one, and then we'll do another one, right? I'm going to simplify all this stuff before I start working on it. Before I start, solving for x, getting x on one side of the equation equal to some value, okay? So, first thing I'm going to do, I have 5 times the difference between a number and 3. And I am going to use my distributive property, okay, to figure that out, right? Remember the distributive property, I'm going to take 5 times x, right? And then I'm going to do 5 times negative 3. Good, negative 15. And that's still going to be equal, I haven't done anything to this side, 2 times x plus 6. Okay, now I have something where I can start working with it. So first thing I'm going to do, you can do multiple different steps first. Okay, I don't want you to get the impression that what I'm choosing is the only starting point. You have some leeway here, right? Some freedom here to decide what you want to start with. I am going to go ahead and subtract 2x from each side, okay? So I'm taking the inverse of 2x, which is negative 2 times x, right? And I'm just subtracting that from both sides, okay? And so I'm going to get 5x minus 2x is just going to give me 3 times x, minus 15, right, unaffected. Right, and we have 6 on this side, because 2x minus 2x is just 0, and anything plus 0 is that thing, right? So 0 plus 6 is just going to be 6. All right. Then I'm going to add 15 to both sides. Okay, so plus 15. Okay. 3x minus 15 plus 15 is just going to be 3x. I have 3x on this side. 6 plus 15 is 21. Okay. Now I have 3 times my number, the number that I'm looking for, is equal to 21. Good, very good. So, I'm just going to divide each side by 3. Right? I'm taking the inverse of 3. Okay. Dividing both sides of the equation by 3, and then I get my solution for my number x. Right, which is 7. Good job for those of you guys that got it. Right, pretty easy. All right, I think you guys probably by now are pretty familiar with this stuff. Right? We're just doing our inverses and applying them to both sides of the equation. Alright. Good. Okay, so when we come back, I'm just going to do one more on the board, and then I'll let you guys... work.
That's what it was.
Bye.